This is going to be problem number 1 on the Stats Garage reference page. I would suggest that you stop the video at this point and do it yourself, and then check what you have against what I'm about to do. Alright, so in that particular problem, first thing to do is to sort out what it is that we have. And if you read the problem, it says the population mean is 78 with a population standard deviation of 9. The sample is 24 rodents. Yes, they're rodents. The sample mean is 75 with a standard deviation of 6. So first check is make sure that you've got that mean is a mu, that mean is an x bar, 9 is sigma, 6 is sample standard deviation. So the first thing to figure out is which test is this going to be? Is this going to be a t-test or a z-test? Well, we've got the population mean sigma, so this is indeed a z-test. And for this test, let us say alpha is 0.05. So the first step in hypothesis testing is setting the hypotheses, getting our heads straight about what we think is going on here, what we're looking for. Right, we're testing for the effect of the amount of this neurotransmitter in these rodents' brains after they do a maze learning task. So these the population these rats come from, right? The population that does the learning task, I'll call them U sub L. They're the ones we don't know about, right? U sub L, we know about the population mean normal situations, but this is a non-normal situation. HO always has an equal sign, and what's it equal? Well, if they're not different, then the population mean for all rats who go through this learning will be no different from the population mean of everybody else. If they are different, and the problem says, did learning affect the level of the neurotransmitter? Affect is a vague word. It's a way of saying change. And it would be a two-tailed test, and 78 carries down as well. All right, so this is a two-tailed test. The rejection region, step 2 of hypothesis testing. I'm going to do it real small here. We're doing a Z. We figured it's going to be a Z test. So 0's in the middle. Two-tailed, right, is less than and greater than. Right, two-tailed does not equal means less than or greater than. So if there's some rejection region there, some rejection region down there, and consulting the table for critical Z values, we see that it is positive 1.96 up there, negative 1.96 there. Those of you who like this in words, the rejection rule, we're going to reject the null hypothesis if what? If the Z we obtain is less than or equal to negative 1.96, or if the Z we obtain is greater than or equal to positive 1.96. All right then, so up here you're accustomed to see me do the third step, calculate the value of the test statistic. Here we're doing a z-test, and remember Z is x bar minus mu sub x bar over sigma sub x bar. And I know from this, I can get these values from the central limit theorem. So what do we have? We have x bar 75, sample mean, minus 78, population mean. And let me just be clear, right? U sub x bar equals mu, which is 78. Sigma sub x bar equals sigma over the square root of n. Right, and I could do it up there, and I think I will because it's a little bit more space there. Right, sigma over the square root of n. Sigma over square root of n. Sigma was 9. The square root of n was, what was n? 24. So 9, the square root of 24 is 4.9. I got a short board, so I'm just going to erase it. Square root of 24 is 4.9. 9 divided by 4.9 is 1.84. So I'll just write that down here and you can see that later. So there's the formula to calculate z. So what do we get? -3 divided by 1.84 gives me a z obtained of -1.63. So here's the time where we do the decision. And I'm not going to switch to blue. Decision and conclusion. So where, first of all, right, the decision. Do we reject or fail to reject? -1.63 is going to be about here, right? There's 0. There's -1.96. Don't need to get it perfect. I just need to know which side it's on. So that's in the region where we'll fail to reject, FTR, fail to reject the null hypothesis. Conclusion, we have no, I'm not going to write that out, we have no evidence that the level of smartazine, that the level of this certain neurotransmitter is different in these rats' brains. Fail to reject, we have no evidence. What else can we say here? We'll do this, even though it may not make sense right now, it will by the end of this chapter. What kind of error have we run the risk of making here? Well, we failed to reject the null hypothesis. That means this could be a possible type 2 error, right? There may really be something going on. There may be differences in this neurotransmitter, just that our test is not able to detect it. I'm just going to put that in a box. If you are watching this before you've read the last section, 10b, then that will make sense. Come back and look at this again after you've read that section. While I have this here too, I'm going to get some double duty out of this problem, right? We set it up. It was a two-tailed test. Let's do a what if. What if the z that we obtained, right? What if the z obtained was, in fact, I'm going to do this. This I'm going to do in a different color. Do this in orange. Just so you know it's different if you're watching this. What is this? In this case, what if the z obtained was -2.01? Well, if we got -2.01, what changes? Well, nothing else changed. We kept the same problem the same. We just changed the results. The rejection region is now down there, right? So the decision for this orange result would be to reject the null hypothesis, and the conclusion would be we have evidence that the level of neurotransmitter in the rat's brains is now different. But that's not a best answer. That's a good answer. We know it's different. Right? The alternative hypothesis, we want to know if it's different. To say it's different in the end is a vague answer. We can go further and say, how is it different? Well, in this case, I know exactly how it's different. There's two ways I know how it's different. One is the result is -2.01 with a z-score. If a z-score is negative, that means the sample mean is less than the population mean. The only way that can happen. We get a result in the lower tail. Lower tail means they're below average. So we could say we have evidence that these rats have significantly less of this neurotransmitter in their brain. The other way it can look, if we reject the null hypothesis, I can look at the sample mean. I can look at the population mean and see the difference. A significant difference means it's real, means it's reliable. I can see that 75 is indeed less than 78, and that tells me that they are significantly below the average.